Question 10. The masses of Fuji apples are normally distributed with a mean of 163 grams and a standard deviation of 6.83 grams. When Fuji apples are picked, they are classified as small, medium, large, or extra large, depending on their mass. Large apples have a mass of between 172 grams and 183 grams. Part A asks, determine the probability that a Fuji apple selected at random will be a large apple. Okay, so our important info is that they are normally distributed, the masses, all right, with a mean of 163 and a standard deviation of 6.83 grams, all right? And large apples have a mass of between 172 and 183 grams. And we want to find the probability that a randomly selected apple is a large apple. Okay, so the way we denote a normally distributed variable or a normal distribution is so a standard letter to use is n. You don't have to do it, but we go x, squiggly line n to represent it's normally distributed. And then followed in brackets, we put the mean, which is mu, and then followed by sigma squared, which is the variance, right? If we apply that to our case here, how we use the letter m for the masses, you can use any letter you like, and then the mean was 163, and the variance would be 6.83 squared, right? Okay, and so we have to find the probability that m is between 172 and 183. Right, so a good way to, a bit of a hint for these questions is to draw yourself a little sketch of a normal distribution of a bell curve, so you can visually see the probability that you're trying to find. So here I've got this one. It's not perfect, but it doesn't have to be even in your exam. It doesn't have to be just a quick little one, and a couple vertical lines to visualize the probability that we're trying to find. So for this one, we are trying to find roughly the probability that a randomly selected apple falls between this range here, okay? Where this lower number would be 172 and this higher number would be 183, okay? And so once again, your calculator is going to do the majority of the heavy lifting here, all right? And so I will show you how to do it on the FX CG500 calculator. Though if, your calculator is different, I urge you to just give it a little Google search or YouTube search of how do I do a normal distribution in your specific model of GDC. And there should be, there'll be plenty of tutorials up there. Okay, so for this one, we go to the statistics section. And I'm sure there's other ways to do it, but this is how I do it. And then I go to calc and then distribution. Right, then I go to normal CD and then bring this down. Our lower bound was 172 grams. Our upper bound was 183. The standard deviation was 6.83 and the mean was 163 grams. Then I push next, and there I have the probability that an apple ranges between these two weights, 172 and 183 grams, and that is 0.0921. All right, so let's bring you back to rounded to 3 significant figures, so I should say. Let's bring you back to the pad. Okay, lovely jubbly. So here we'll put in 0.0921. Okay, and so that is the answer to part A. All right, let's move on to part B. So where am I going? I'll start that down here. Approximately 68% of Fuji apples have a mass within the medium size category, which is between K and 172 grams. All right, and we're asked to find the value of K. So 68% of Fuji apples have a weight between K and 172. Right, we asked to find the value of K. So here, if we represent this in sort of, or if we write down the probability that we're trying to find, or sorry, no, what we've got given in the question here is we're told that the probability of a randomly selected apple being between K and 172 grams is equal to 0.68. Okay, and so if we once again bring in our normal distribution curve and have a look at this visually. So we'll say 172 is roughly this line here. And we'll say, let's say K is going to sit around here, let's say. All right. And so K, 172 here. And we are asked to find, well, no, we are told that this area in here is equal to 0.68. Now, when I say the area, that is the probability that the mass sits between these two values, and the total area under the normal distribution curve is equal to 1. Okay, and then also, what should be useful to know is that if you go to the left of the mean, all right, so anywhere this way, that represents 0.5 or a probability of 0.5 or the area of 0.5, and same as if you were to go to the right. So if you just go this way of the mean, all those values will be, or the probability of getting any of those values is 0.5 or 50%. Now, so we need to find, obviously, the value of K, and there are a number of ways you can go about this. Though what I think will be the best way is if we were to find the area to the left of 172, okay? So all of this, let's zoom in, all of this, okay? And we find that value, okay? And then we substitute 0.68, which is this middle area, we would be left with this. That's what we would be left with. And then that would give us the probability of an apple being less than K, okay? And so then from there, that will help us find K. So if I write what I've just tried to sketch out, I apologize for that not being overly neat, but if we're trying to try and find the probability that a randomly selected apple is less than K, what we can do is say this is going to be equal to the possible probability that a randomly selected apple is less than 172 grams, subtract 0.68, okay? And so then to just show that, and how about we do this? We'll take this. I'll take this back, but just so I can show that, we're going to find this area here. All right, and then subtract our middle area, 0.68, and then that will leave us with the probability that a randomly selected apple is less than K grams, okay? So let's go back, put that back up there. All right, cool. Now so we're going to go back to our calculator, and we're going to find out the probability that a randomly selected apple is less than 172 grams. All right. And so let's go. Okay, I'll do this again. So with this one, we go to the statistics section, or I do. There will be other ways to do this. Then go to distribution. I want normal CD, and I want to find the probability that a randomly selected apple is less than 172. I'm going to use the lower bound of 0, upper bound of 172, standard deviation of 6.83, and the mean being 163 grams. Okay, and so that gives me a probability of 0.9062 We'll just go to the four decimal places. So 9062. Okay, so let's come back to the pad and we'll put that in. It's going to pop up any second. Nice. So the probability of this being less than k is equal to what we just found for this one. So that was 0.9062. Subtract 0.68. And if we do that, we'll bring this over. What's it? 0.9062 subtract 0.68. Go. So 0.2262. All right, so 0.2262. All right, so now I know the probability that a randomly selected apple is less than k grams. So if we were to denote that with we have now just found that if we bring here, we'll say this is k, we have found that this area under here is 0.2262. Okay, and then so now with this bit of information, we can go back to our calculator and use the inverse normal function, which will then give us the value of k. Right, and so I'm going to bring you back to the calculator and show you how we do that. Okay, so we'll back it up from here. In fact, we'll start again. So statistics, calc, distribution, oh, no, beg pardon. Statistics, calc, and then this time we're going to need to go to inverse distribution. Okay, so inverse distribution, inverse normal CD. So that's correct. We've got that all in there. Okay, and so then here, so this tail setting, remember back from what we had in the pad, we need to find the range or the value, or our tail setting needs to be to the left, okay, because we've found the probability that a randomly selected apple is less than k grams, all right? We have to change this to left. The probability that we found was 0.2262. That was right, yeah. Our standard deviation is 6.83, and our mean was 163. Okay, we click go, and here we have 157.8678 grams for k, and so rounded to three significant figures, we would get 158 grams. So let's come back to the pad, and we will put that in. Cool. And so we'll put therefore k is equal to 158 grams. And there is the answer to part 10.